Apologies about that. We got cut off then. My youngest daughter needed the potty, so who am I to not allow that to happen? So we'll pick up exactly where we left off, which I think was me turning from page 11 to 12. Quite a lot of this booklet I've already filled in, okay, so I'll just talk you through the bits that I think are a little bit strange or you know, might catch you out. There isn't a lot though. The first thing I want to say about these two, they're the calculator versions of tree diagrams, okay? A little bit harder. This one has got some decimals and some fractions. Same rules though. Let's get the red to do this. Same rules. Multiply. Think of that as a line down the middle, so if you want that followed by that, you times those together and so on. Same thing we've been talking about throughout, okay? When you put into your calculator a decimal times a fraction, the Casio is likely to give you an answer as a fraction, okay? I pressed that SD button and changed it into a decimal. I just thought it would be nicer possibly to have them in decimals just to work with in my part B's, okay? There's no harm leaving them as fractions, but for adding them together at the end, probably easier to add decimals on a calculator than fractions, what I thought, okay? I didn't like the wording down here either. What is the probability that a member chosen at random was not one of those who travelled by bus on the first day of the show? Okay, these are the guys that travelled by bus on the first day of the show. It's this line here. So the probability of travelling by bus on the first day of the show is that. All these are not travelling by bus on the first day. They're either travelling by bus on the other day or travelling by car on the first or other day. So that's why you can see these ticks. Two options, I guess, because these are the three that apply to this situation. You either add them up, okay, or you can take that away from one, because basically everything else is what you're looking for. On this one, the second page here, all I would say, unusual to see three branches, but stick to the same rules. Multiply, all right, multiply anything you need and add together all the combinations you need. So the question here, what is the probability that a player will select a black ball? Well, you can either have this path, which is A with a black ball, B with a black ball, C with a black ball. Written there, A black, B black, C black. Could have done this working out here, chose to do it here this time, okay? A times black, B times black, C times black, add them all together. We're on to the harder stuff. Conditional probability. So it's the same rules. We're still multiplying, okay, for if we need something followed by something, and we're still adding together all the combinations that apply to us. What will I say? Okay, we're looking at things that are without being replaced. So balls, marbles, cards that are not put back in the box or bag that they're taken out of. You can draw probability trees to help you. I think you guys are good enough to just do it without, okay? But my word of advice is not to forget, I don't know if you can see that there, don't forget reverse combinations. If it says you're looking for a red and a blue marble, that could be red followed by blue or blue followed by red, unless you're specifically told you need a certain order, red followed by blue, okay? I'll keep on mentioning that throughout these. So I do want to talk you through this one. It would have been nicer if I hadn't filled this in and could have done it now for you, but I can chat you through it. Find the probability that the product of the two numbers, I should say, we're taking two cards here out and not replacing the first one when we take the second one. The product of the two numbers selected is 12. When I multiply the two numbers together, I get 12. So 2 times 3, no. 3 times 4, 3 times, no. 3 times 4 is the only way to do it. Or, and this is important, the reverse combination, 4 times 3. You can see I've written there. Either 3, 4 applies or 4, 3. For 3, 4, I've looked at the probability of getting a 3, which is 2 out of 6, and multiplied it by the probability of then getting a 4, which is 3, but now out of 5, not 6 cards. I've done the same for 4, 3, 3 out of 6 times 2 out of 5. Worked both out, added them together, and left the fraction as 12 over 30. No need to simplify unless they tell you differently. Part B was, what's the probability the sum of the two numbers selected is even? You just got to look at all the combinations again. 2 add 3 is 5, that's odd. 2 add 4 is 6, that's even. 3 add 3 is 6, that's even. But But don't forget any reversals as well. So 2 add 4 is even, but 4 add 2 is also even. So my 3 combinations that will apply here are written here. Again, I won't talk you through it. I've worked out the probability of each combination multiplying. Each time you notice the 6 going down to a 5 because we're a card less. There are my 3 answers. Add them all up. And again, don't bother simplifying. Just leave it as it is. Okay, we'll do Ralph's Strawberry Chocolate. Ralph is in a dark cinema. Okay. Ralph selects 2 chocolates at random from a box. There are 20 in the box and 5 are strawberry flavoured. It's wording again. Get the wording, you're in. Calculate the probability that at least one of the chocolates Ralph selects is strawberry. If neither are strawberry, he has no strawberries. If he has a strawberry followed by a strawberry, then he's had at least 1. If he has a strawberry followed by a not strawberry, then he's had at least 1. But again, those reverse combinations, he could also have that the other way around, a not strawberry followed by a strawberry. Again, there are my 3 workings, okay? I would work them out individually with my calculator or in my head and add them together. This little red note here says there was an alternative here. Because the only combination I've not taken is not strawberry, I could have worked backwards, worked at the probability of having 2 not strawberries and taken it away from 1. Okay, I might talk you through all this page actually, and then let you kind of flick on and mark your own. We're on to blocks now, and coloured blocks. Question 1 here is a very specific order. First block removed is red, second is green, third is yellow. So it must be in that order: red, green, yellow. 6 out of 12 are red. 4 out of 1 block less now are green, 11. Okay, and then 2 out of, and again 1 block less again, so we're down to 10 blocks now. 2 out of 10 are then yellow. Multiply them all. 6 times 4 times 2 is 48. 12 times 11 times 10 is 1,320. Poppy, what about the probability that all 3 blocks will be the same colour? Well, I could get red, 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 or maybe green, 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 or yellow, yellow, yellow. But you can see I've crossed this out. Why? Well, there are only 2 yellow blocks, so the chances of getting 3 yellows in a row, if there are only 2 in there, I would think are non-existent, so we won't waste our time with that. Red, 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 here they are. Green, 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 here it is. Worked both out, added them together, final answer, won't simplify. And then I noticed that this last little guy here was a 1 marker, suggesting to me there's not a lot of work to do. Write down the probability that the 3 blocks will not be the same colour. Right. If you did this properly, it would take you forever. There are so many combinations with different colour blocks. Red, green, yellow, red, red, yellow, green, red, yellow. You get the idea. By the time you list them all, work them all out and add them together, you'll be there all day. However, the probability that the 3 blocks will not be the same colour is 1 take away the probability that the blocks will be the same colour, which we've worked out here. Okay, so 1 take away that, and I've worked out that out there, 1,176 over 1,320. I keep saying it, don't simplify unless they ask you to simplify. A nice one with calculator allowed, pretty self-explanatory. Take a look at it, make sure you're happy. The only thing I would say is, because I used my calculator, when I've multiplied these, my calculator has already simplified it to 1 over 12. Okay, if you'd done it separately, you'd have had something like 60 over 720, I think it is. Okay. But the calculator's done that for me. It wouldn't matter either way. If you left it as 60 over 120 plus 60 over 120 is 120 over 720. I'm just as happy. Take a look. Make sure you are happy there. Okay. Quite a lot of combinations here. I was trying to think if there's a way I could save myself time. Find the probability of picking at least 1 red ball. Potentially we could have looked at combinations that involved not picking at least 1 red ball and taking it away from 1, but when I listed them all there wasn't much in it, so I've gone with red red, red green, the reverse of red green, which is green red, red pink and the reverse of red pink, which is pink red. Worked them out individually, added them all together. This is a little bit of a nasty one, because you've got to know about combinations of even and odd and whether they give even answers or odd answers. So take a little bit of time and make sure you're happy with that. Finally, something I can do. Here we go. A factory produces a very large number of beads which are either coloured red or coloured blue. The beads are identical in all other respects. The probability of randomly chosen bead being red, is 0.7. That tells me that the probability of it being blue is 0.3. The beads are randomly packed in boxes of 20 beads. What is the expected number of red beads in a box? Okay, a slightly new type of question, I guess, but if the probability is 0.7 and there are 20 of them, just have to multiply those together with my calculator. You wouldn't need a calculator. 7 20s are 140, and put a decimal place in to make 14. This caught a lot of people off when this question was asked by the WJEC. Okay, a particular box is known to contain the expected number of red and blue beads. 2 beads are chosen at random from this box without replacement. Show that there is less than 8% chance that both beads are blue. Okay, so in an expected box, okay, I was expecting 14 reds. So that meant I was expecting 6 out of 20 to be blue, okay, followed by another blue. Well, now we'd be down to 5 out of 19. Multiplied together is 30 over 380. Get my calculator. I'd like to see that as a decimal. It is 0.079, so multiplied by 100, that's 7.9%, so a little bit less than 8%, and we've proved what they need me to prove. We're going to look at one more here. Rain, probability of rain, 80% on Monday, 80% on Tuesday, 80% on Wednesday. I've written next to it the probability of therefore not having rain is 20% on each day. A little bit like what I did here, looking at if this is the probability of this happening, what's the probability of it not happening. Calculate the probability that it will rain on 3 days. The only combination that applies there is rain, rain, and more rain. So 0.8 times 0.8 times 0.8. Notice I've used decimals instead of percentages and left my answer as a decimal. Calculate the probability that it will rain on exactly 2, and then the interesting word consecutive. It threw me initially, okay? Because if it had said exactly 2 days, then there are 3 combinations. Rain, rain, no rain. Rain, no rain, rain. No rain, rain, rain. But only 2 of those combinations involve the rain being on consecutive days, either on the 1st and 2nd but not on the 3rd, or on the 2nd and 3rd but not on the 1st. Okay, both probabilities have been worked out of both combinations. They happen to be the same, okay, and then added together to get my final answer here. I think I'll stop there, and I might do the final 2 parts in a part 3 if you're happy with that, and I shall speak to you all soon.